You love a refreshing dip on a hot day, right? Crystal clear lake, cool water washing away your worries. But what if I told you that lurking beneath that sparkling surface could be a microscopic monster with a taste for brains? That's right. We're talking about Naegleria Fowleri, also known as the brain-eating amoeba. Don't freak out just yet, but stick around because today we're diving deep, pun intended, into this fascinating and terrifying organism. We'll uncover where it lives, how it infects humans, and what you can do to protect yourself. So grab your metaphorical hazmat suit and get ready for a wild ride into the world of the brain-eating amoeba.
The year was 1965. In the sun-drenched landscapes of Australia, a chilling discovery unfolded. The serene beauty of the land masked a lurking danger that would soon come to light. A string of deaths, as swift as they were inexplicable, gripped a small community. Families were left in shock and despair as their loved ones fell victim to an unknown menace. The victims, all seemingly healthy, succumbed to a rapid and devastating brain infection. The speed and severity of the illness left doctors baffled and desperate for answers. Panic rippled through the community as doctors and scientists grappled for answers. Hospitals were overwhelmed, and the air was thick with fear and uncertainty. What unseen force was claiming lives with such ruthless efficiency? The search for the cause became a race against time as more lives hung in the balance. The culprit, they soon discovered, was a microscopic predator lurking in the warm freshwater lakes and rivers, Naegleria Fowleri. This tiny organism, invisible to the naked eye, was the harbinger of death. This single-celled organism, an amoeba of inconspicuous appearance, harbored a terrifying secret. Under the microscope, it revealed its true nature, a deadly predator with a sinister agenda. It possessed an insatiable appetite for human brain tissue, earning it the grim moniker of the brain-eating amoeba. Once inside the human body, it would travel to the brain, causing irreversible damage. The discovery sent shockwaves through the scientific community, forcing humanity to confront the reality of microscopic predators lurking in the most unexpected places. Researchers were stunned by the amoeba's lethal efficiency.
This early encounter with Naegleria Fowleri served as a stark reminder of the power of the unseen world. It highlighted the vulnerability of humans to the hidden dangers that exist in our environment. It underscored the delicate balance between humanity and the microbial world, a world teeming with both beneficial and potentially deadly organisms. The incident emphasized the need for vigilance and respect for the natural world. The story of Naegleria Fowleri is a story of scientific discovery, of the constant battle against infectious disease, and of the profound mysteries that still lie hidden within the microscopic world. It is a tale of human resilience and the relentless pursuit of knowledge in the face of terrifying unknowns. Scientists around the world continue to study Naegleria Fowleri, seeking to understand its behavior and find ways to prevent future outbreaks. Their work is a testament to the enduring quest for scientific understanding and the protection of public health. In response to the threat, community awareness programs and safety measures have been implemented to educate the public about the risks of swimming in warm freshwater bodies. These efforts aim to prevent further tragedies and ensure the safety of all. As we look to the future, the haunting discovery of Naegleria Fowleri serves as a reminder of the challenges we face in the microscopic world. Yet it also inspires hope, as scientific advancements continue to pave the way for a safer and healthier world. In the face of such a formidable foe, the medical community has rallied to develop treatments that can combat Naegleria Fowleri infections. The primary treatment regimen involves a potent combination of drugs, each with a specific role in attacking the amoeba. Amphotericin B, a powerful antifungal, is often the cornerstone of the treatment. It works by binding to the amoeba's cell membrane, creating pores that lead to cell death. This drug, however, comes with significant side effects, making its administration a delicate balance between efficacy and patient safety. Rifampin, another key player, is typically known for its role in treating tuberculosis. In the case of Naegleria Fowleri, it acts synergistically with other medications, enhancing their effectiveness and providing a broader spectrum of action against the amoeba. Miltefosine, originally developed as an anti-cancer drug, has shown promise in treating parasitic infections, including those caused by Naegleria Fowleri. It disrupts the amoeba's cellular processes, leading to its demise. This drug has been a game changer, offering new hope in the fight against this lethal pathogen. Early diagnosis and prompt initiation of these treatments are crucial for improving survival rates. Rapid intervention can mean the difference between life and death, as the infection progresses swiftly and can be fatal within days. The battle against Naegleria Fowleri is a testament to the resilience and ingenuity of the medical community. With continued research and advancements in treatment protocols, there is hope that we can reduce the mortality rate associated with this terrifying infection. Please subscribe to Sci Sips and like the video for more fascinating insights into the world of science.
Naegleria fowleri's deadly dance begins in warm, freshwater environments, often unnoticed by humans. Here, in its dormant cyst form, it can lie in wait for unsuspecting victims, biding its time. When disturbed water carrying these cysts enters the human nose, typically during activities like swimming or diving, the amoeba seizes its opportunity to invade. Propelled by its whip-like flagellum, Naegleria fowleri embarks on a treacherous journey through the nasal passages, moving with purpose. It navigates towards the olfactory nerves, the sensory nerves responsible for our sense of smell, with deadly precision. These nerves provide a direct pathway to the brain, bypassing the body's usual defenses, making it vulnerable. Once inside the brain, Naegleria fowleri transforms into its active amoeboid form, ready to wreak havoc. It begins to multiply rapidly, feasting on brain tissue and triggering a catastrophic inflammatory response, causing severe damage. This assault on the central nervous system leads to a condition known as primary amoebic meningoencephalitis, a rapidly progressing and often fatal brain infection, leaving little hope for recovery.
Let us now delve into the fascinating and often terrifying world of pathogens that have developed the ability to invade the human brain. These microscopic invaders employ a variety of strategies to breach the brain's defenses, posing significant threats to human health. Naegleria fowleri, while terrifying in its own right, is not alone in its ability to penetrate the brain. This single-celled organism, often found in warm freshwater, can cause a rare but devastating infection known as primary amoebic meningoencephalitis, PAM. Once it enters the nasal passages, it travels to the brain, leading to severe inflammation and, in most cases, death.
Other opportunistic pathogens, often lurking unnoticed in our environment, possess similar strategies for breaching the blood-brain barrier, a protective shield that normally safeguards the brain from infection. These pathogens have evolved various mechanisms to bypass or disrupt this barrier, allowing them to invade the central nervous system and cause serious diseases.
Cryptococcus neoformans, a fungus found in soil contaminated with bird droppings, enters the body through inhalation. Once inhaled, it can disseminate through the bloodstream to the brain, where it causes cryptococcal meningitis. This infection is particularly dangerous for individuals with compromised immune systems, such as those with HIV/AIDS.
Like Naegleria fowleri, it targets the central nervous system, causing a severe form of meningitis, particularly in individuals with weakened immune systems. The symptoms of cryptococcal meningitis can include headache, fever, neck stiffness, and altered mental status, making it a serious and potentially fatal condition if not promptly treated.
Listeria monocytogenes, a bacterium commonly found in contaminated food, employs a different tactic. This pathogen can be found in a variety of foods, including dairy products, deli meats, and raw vegetables. When ingested, it can cross the intestinal barrier and spread to the bloodstream, eventually reaching the brain.
It hijacks the body's own cells, using them as Trojan horses to cross the blood-brain barrier and invade the brain, leading to a potentially life-threatening infection called listeriosis. This infection can cause symptoms such as fever, muscle aches, and neurological issues, and is particularly dangerous for pregnant women, newborns, the elderly, and individuals with weakened immune systems.
These examples highlight the vulnerability of the human brain to opportunistic invaders, and the critical importance of understanding the diverse mechanisms by which pathogens can breach its defenses. By studying these mechanisms, scientists hope to develop better strategies for preventing and treating infections that target the central nervous system, ultimately protecting human health from these hidden threats. Section 5. Echoes of a Silent War: Antibiotic Resistance and the Future of Microbial Defense. The rise of antibiotic resistance casts a long shadow over our fight against infectious diseases, and Naegleria fowleri is no exception. This microscopic organism, often referred to as the brain-eating amoeba, has become a symbol of the broader issue of microbial resistance. As we delve deeper into this silent war, it becomes evident that our current strategies may not be sufficient to combat these evolving threats.
While effective treatments for PAM remain elusive, some antibiotics have shown promise in laboratory settings. However, the emergence of drug-resistant strains poses a significant challenge. These strains not only complicate treatment protocols, but also increase the mortality rate associated with infections. Researchers are tirelessly working to identify new compounds and treatment regimens, but the pace of resistance development often outstrips our efforts.
The indiscriminate use of antibiotics in healthcare and agriculture has fueled the spread of antibiotic resistance genes among bacteria, including those that Naegleria Fowleri may encounter in the environment. This widespread misuse and overuse of antibiotics create a breeding ground for resistant strains, making it increasingly difficult to manage infections. The agricultural sector, in particular, plays a significant role in this crisis, as antibiotics are often used to promote growth in livestock, further exacerbating the problem.
This horizontal gene transfer can equip Naegleria Fowleri with new defenses, rendering existing treatments ineffective. The mechanisms behind this gene transfer are complex and multifaceted, involving various genetic elements that can move between different organisms. Understanding these mechanisms is crucial for developing strategies to counteract resistance and protect public health.
Addressing this global threat requires a multifaceted approach. This includes developing new antibiotics and alternative therapies, promoting responsible antibiotic stewardship, and fostering research into the complex mechanisms of antibiotic resistance. Innovative approaches, such as phage therapy and the use of antimicrobial peptides, are being explored as potential solutions. Additionally, public awareness campaigns and education on the responsible use of antibiotics are essential to curb the spread of resistance.
The battle against Naegleria Fowleri and other emerging pathogens serves as a stark reminder of the interconnectedness of human, animal, and environmental health, urging us to adopt a One Health perspective in tackling these challenges. This holistic approach recognizes that the health of people is closely connected to the health of animals and our shared environment. By integrating efforts across multiple sectors, we can develop more effective strategies to combat antibiotic resistance and safeguard our future.
Did this video blow your mind? Smash that like button and subscribe to Sci Sips. Let us know what other scary science topics you want to see in the comments.